Namaskar, I am Biju Dharmapalan and you are watching Science Time, a show that brings you the latest developments from the world of science and technology. Let's first look at some of the exciting stories. Google's quantum computer hits key milestone by reducing errors. New space radar will hunt planet-threatening asteroids. Scientists discover new protein activity in telomeres. Now let us see the news in detail. Physicists at Google have reached what they describe as their second milestone along the path to a useful quantum computer. At a laboratory in Santa Barbara, California, they have demonstrated that they can lower the error rate of calculations by making their quantum code bigger. The feat, reported in Nature on 22nd February, follows up on a celebrated 2019 experiment in which a Google quantum computer achieved quantum advantage by performing a calculation that would have taken thousands of years on an ordinary computer. Error correction is an inescapable requirement if quantum computers are to be fulfill their promise of solving problems that are beyond the reach of classical machines, such as factoring large whole numbers into primes or understanding the detailed behavior of chemical catalysis. All computers are subject to errors. An ordinary computer chip stores information in bits, which can represent 0 or 1, and copies some of the information into redundant error correction bits. When an error occurs as a result of stray electrons crossing an imperfectly insulating barrier, say, or a cosmic ray particle disturbing the circuit, the chip can automatically spot the problem and fix it. Quantum computers are based on quantum states called qubits, which can exist in a mixture of 0 and 1 states. A qubit cannot be read out without its full quantum state being irretrievably lost, which means that its information cannot be simply copied onto redundant qubits. Now the Google team has shown it can reduce errors by spreading the information more and more qubits. Such scaling marks a key step forward Google's goal of maintaining indefinitely 1 qubit's worth of information, a logical qubit, by encoding it on 1,000 physical ones. A full-fledged quantum computer could perform certain tasks such as cracking current internet encryption schemes that overwhelm a conventional computer. Now let's move to the next story. Astronomers have used a radar to probe the planets and asteroids around us, measuring their speed as they whiz around the sun and imaging the details of their surface. A new tool promises to ramp up this brand of science by offering more detailed astronomical radar capabilities than ever before. The team behind a pioneering radar system at the Green Bank Telescope in West Virginia released their first results at the 241st meeting of the American Astronomical Society, revealing unprecedented detail on the moon and detecting a near-Earth asteroid. The telescope's novel radar system, called Next Generation Radar or NG Radar, produced results that were beyond expectations. The Next Generation Radar system uses the Green Bank Telescope as a huge transmitting antenna, and it uses the very long baseline array of radio telescopes spread across the US, Hawaii, and the Virginia Islands as a miles-wide receiver. Green Bank has a 100-meter diameter dish, a radio telescope's equivalent of a mirror, making it the largest steerable antenna on Earth, uniquely suited to this job. Now let's move to the next story. Once thought incapable of encoding proteins due to their simple monotonous repetitions of DNA. Tiny telomeres at the tip of our chromosomes seem to hold a potent biological function that's potentially relevant to our understanding of cancer and aging. Reporting in the proceedings of National Academy of Sciences, the UNC School of Medicine researchers made the stunning discovery that telomeres contain genetic information to produce two small proteins, one of which they found is elevated in some human cancer cells as well as cells from patients suffering from telomere-related defects. According to the researchers, this discovery will help in developing simple blood tests for these proteins that could provide a valuable screen for certain cancers and other human diseases. These tests also could provide a measure of telomere health because we know telomeres shorten with age. Let's move to Science Quest segment. The question for this week's Science Quest is, why does one nostril get blocked when you are sick? It's down to what's known as the nasal cycle. We might not realize it, but our bodies deliberately direct the airflow more through one nostril than the other, switching between nostrils every few hours. A constant airflow can dry out the nostrils, which damages their lining, so giving one nostril a rest helps prevent this from happening. When we have a cold, the blood vessels in the nose dilate as part of the body's immune response, and the nose also produces more mucus. Both of these changes cause congestion, but you will feel more blocked in the nostril that is currently off duty. The nostril with the full airflow might feel fine. With this, we come to the end of this edition of Science Time. Keep sending your feedback and suggestions through email. Our email ID is indiascience@vigyanprasad.gov.in. We will be back with more exciting stories from the world of science next week. Stay tuned to India Science.